Welcome back. Now we're gonna actually talk about 4.4. Let me actually slideshow. Okay, so at 4.4, we'll be still looking for the relationship between two variables. In the previous sections, we talked about the relationship between two variables when those two variables are quantitative numeric values, such as shoe size or height. And this time in the 4.4, we'll be talking a little bit about what if those two variables are categorical, qualitative data sets. So to introduce that, we will be using one of the survey, class survey examples. We're going to stick with the pet preference versus residence. So this particular contingency table, so table look like that, we just call it contingency table. There are two variables going on. Two different things going on. For here, you can see the pet preference in the residence. And this particular one is generated from the StatCrunch. So this is our class survey. Notice that dog versus cat variable has cat, they like cat, or they don't like dog, or they don't like any of them, neither or both. So there are four different categories. And there's a on-campus and off-campus. So that's a student residence. So if you go stat and table and contingency with data, and then you put the row, I mean, it doesn't really matter which one goes to the row and which one goes to the column. But this time we're going to just put the dogs versus cats as a row and on or off campus for column. That's all you need to do and compute. Okay, you don't need to worry about the chi-square test, that part yet. And this is exactly the table that we just saw in our PowerPoint slide. Okay, so I just copy and pasted it there. Okay, so that's the table once more. So using this example, we'll think about different distribution, different percentages here. So the one of the way that you can read this table is you can see that there is total of 314 people answered this survey, right? But if it's a actual total number of respondents. And out of 314 students, there are 23 students are living off campus and they prefer both dogs. They love both cats and dogs. There are 10 people who answered that they live on campus and they don't like neither of dogs or cats. So those are 8 different categories here, right? And then you notice that these numbers are totals. So 122 is the total of 23 plus 11 plus 80 plus 8, and 72 is this 23 plus 49. Okay, that's how the contingency table is structured. Using this table, we'll think about marginal distribution, marginal percentage, marginal probability. Once we actually talk about probability in chapter 5, we'll probably use the word probability, marginal probability. But for this chapter, we'll just keep use of percentage, which is actually same thing. So let's suppose that we want to answer what is the percentage of students who love dogs. Okay, so in this table, if you see it, these are the dog lovers, right? These are the dog lovers, and which is, if you add those two numbers, 178% answered that they actually love dogs. So you can say 178 out of 314, which is 0.5669. So about 56.69% of students love dogs. You can say that. Okay. The second one is, what is the percentage of students who live on campus? So all these people live on campus, and this is actually a total. So 192 out of 314. Which is 6115. So 61.15% of students live on campus. So the key point of the marginal distribution is using contingency table, the actual numbers in the cell is kind of joint thing, that there are two different things happen at the same time. For example, this number is the person lives off campus and like both pets, right? But marginal probability, marginal distribution, marginal percentage is we are actually going back to only one thing. So we are talking about what's the percentage that the students actually love dogs. Doesn't matter whether they live off campus or on campus. And the second one is it doesn't really matter their pet preference, but we only care about one thing, which is they live on campus or not. So that's marginal distribution, marginal percentage. The next thing we're going to look at is conditional distribution and percentage. For example, how can we answer what is the percentage of off-campus students who love dogs? So among the off-campus students, how many of them are actually love dogs? So instead of counting all the numbers, 314, all the respondents, we this time limit our population as off-campus student. So there are 112 off-campus students. Out of that, there are 80 dog lovers, right? So .6557. Okay, so 65.57% of off-campus students love dogs, right? You can say that. Second one, what is the percentage of cat lovers who live on campus? Okay, so there are cat lovers. How many cat lovers? 46 cat lovers. And then how many of them are actually live on campus? 35. Is 0.7609. So that's the probability or percentage of cat lovers who live on campus. That's one way that we are giving from conditions. So we call it conditional distribution and conditional percentage.